everybody. Stay safe and secure. Now, this is the third module about force. In this module, we are going to discuss about the non-contact force and their types. We need not memorize anything if we understand the basic concepts. This video make you understand the concepts and make you cool. Non-contact force. A force that one object exerts on another when they are not touching is called non-contact force. For example, a magnet can attract iron nails from a distance. Magnetic force is therefore a non-contact force. The gravitational force of the earth is a non-contact force which attracts all the bodies towards the earth. The electrostatic force which can pull tiny bits of dry paper is also a non-contact force. So, non-contact forces include the gravitational force, electric force, magnetic force and electrostatic force. We have seen the contact force and their types. Now, let's see the non-contact forces. The first example for non-contact force is electrostatic force. The force exerted by the electrically charged body is called electrostatic force. This force acts from a distance. Therefore, it is a non-contact force. Example: a plastic straw charged by rubbing with paper attracts the suspended plastic straw. A plastic straw charged by rubbing with paper repels another suspended plastic straw charged by rubbing with paper. We have seen the electrostatic force. Now, shall we see an activity for the effect of electrostatic force? Take a home or plastic pen and rub it on almost any piece of fabric. It will acquire a small electric charge. If placed near small bits of paper, they will be attracted. When two objects are rubbed together, the molecules are close enough together that the electrons from one substance can move on to the other substance. We have seen the electrostatic charge attracts the pieces of paper with a force which is called electrostatic force. Now we are going to see another activity. Take a balloon and inflate it. Next, rub it on your hair for a few moments. Now place it against the wall. The balloon will stick to the wall. This is because of electrostatic force. When a balloon is rubbed against the human hair, electrons are transferred from the hair to the rubber, giving the balloon a net negative charge and leaving the hair with a net positive charge. As the balloon is pulled away, the opposite charge on the hair causes it to be attracted to the balloon. The electrostatic forces used to remove solid pollutants like carbon and ash from smoke coming out of the factories. This helps in reducing air pollution. An electrostatic precipitator is a type of filter that uses static electricity to remove soot and ash from exhaust fumes before they exit the smokestacks. Unburned particles of carbon in smoke are pulled out of the smoke by using static electricity in the precipitators, leaving hot air to escape the smokestacks. Gravitational force. The force of attraction between any two particles in the universe is called gravitation or gravitational force. For example, moving of planet around the sun in universe or falling of apple from the tree towards the earth. The gravitational force was first discovered by Sir Isaac Newton when he saw an apple falling from a tree. In space, all heavenly bodies like the moon, the planets and the stars exert force of attraction on objects. The bigger and the heavier the body is, the greater is its force of gravity. Gravitational force exerted by moon on an object is less than the gravitational force exerted by earth on the same object. Actually, the moon's gravity is only 1/6 that of the earth. It means that if an object weighs 240 kg on earth, it will weigh only 40 kg on the moon. On the moon, you can lift weights which are 6 times heavier than the weights you can lift on earth. All objects, when let go down, fall freely towards the ground. The earth's gravity stops objects from going up. When a ball is dropped from a height, its speed goes on increasing. The speed of a ball increases because the earth applies a pulling force on it, which is called a force of gravity. On the other hand, when a ball is thrown upwards, then its speed goes on decreasing. This is because the earth applies a pulling force of gravity on the ball in the downward direction. We have seen the force of gravity depends on the mass of the object and their distance from each other. Objects with larger mass have a larger force. Therefore, an object with more mass will have more weight. The force by which earth attracts a body is called the weight of the body on the earth. We measure weight with a device known as spring balance. Mass of a body is measured in kilograms, whereas the weight is measured in newtons or kilogram force. Distance between object and the earth also affects the gravitational force. Spacecraft moves beyond the earth's gravitational force, while a ball thrown high in air comes back to the earth. The gravitational force of earth can hold all the things with it. Gravity is dependent upon the mass of two objects and the distance between them. If the mass increases, then the force of gravity also increases. If the distance increases, then the force of gravity decreases. Jupiter has more mass than Earth. Therefore, it has more gravity. The satellite is farther from the center of the Earth than we are. Therefore, the planet is not pulling as hard on the satellite as the person standing on the surface. Shall we see an activity to see the effect of gravity on the objects of different masses? Aim: to see the effect of gravity on the objects of different masses. Materials required: feather and a small stone. Procedure: take a small stone in one hand and a feather on the other hand. Drop both of these objects simultaneously. Observation: we can observe that the stone hits the ground first with greater force than the feather. Conclusion: this happens because the stone has more mass than the lighter feather and the force of attraction on it is also greater. Spring balance. Spring balance is a device which is used to measure the weight of the body. Procedure: the object to be weighed is attached to the hook of a spring balance, which is held vertically either from the hook or with the hand. The spring gets stretched due to the gravitational pull and hence the pointer slides downward on the engraved scale. The weight of the object is read from the position of the pointer on the scale. Magnet was discovered some 5000 years ago in Magnesia. There is a very interesting legend behind the discovery of magnetism. It is said that magnetism was discovered by a Greek shepherd named Magnus. He found that the iron in his stick and the iron nails of his sandals had got stuck to a large rock on which he is standing. This is a strange rock which named Magnus Lithos, the stone from Magnesia. Its special feature was the ability to attract and lift small pieces of iron. This ability is known as magnetism, and the material having this ability is known as a magnet. Now, we are going to learn magnetic force. Magnetic force is a non-contact force. What is non-contact force? The force which acts from a distance without any physical contact is called non-contact force. Now, what is magnetic force? The force exerted by the magnet is known as magnetic force. There is an attraction or repulsion between the parts of the magnets. Like poles of two magnets repel each other, and unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. Hence, it is known as a non-contact force. Now let's see some of the important properties of magnets. Magnets has two poles. These are the ends of the magnets where the magnetic force is strongest. When a magnet is suspended freely, it comes to rest in the north-south direction. Magnet always attracts objects made up of iron and steel. Poles always exist in pairs. They cannot be separated. We have already seen magnetic force acts from a distance. Therefore, it is a non-contact force. Magnets cast a force around them. The area of force around the magnet is called magnetic field. We cannot see the magnetic field. The earth also has a magnetic field. It is surrounded by magnetic lines of force. The earth also has a magnetic field. It is surrounded by magnetic lines of forces. We can use magnetic compass to see the magnetic fields of earth. Magnetic compass is used for showing the directions. It can be used to detect the magnetic fields near you. Can we able to see the magnetic lines of force? We cannot usually see the pushing and pulling force around the magnet. But by scattering some iron filings on a piece of paper and placing a magnet under the paper, some of the lines of the magnetic force can be clearly seen. The next non-contact force is nuclear force. Nuclear force acts among the small particles in the central part of the atom, which is called nucleus. They are very strong non-contact forces which held the particles together. Unlike gravity and electromagnetism, the strong nuclear force is a short distance force that takes place between the fundamental particles within the nucleus. It is charge independent and acts equally between a proton and a proton, a neutron and a neutron, and a proton and a neutron. There are many natural forces whose effects we can see. Strong winds, storms, and hurricanes can exert much force and cause damage to houses, people, and other living things. Running water can exert a force. In villages, this force is used to turn a wheel which grains. When the hydropower is harnessed from the source to produce electricity, then it is called hydroelectric power. Through the hydropower, the energy in falling water or fast running water is converted into electricity without using up the water. The setup which is constructed to derive the electrical energy from hydropower is called hydroelectric power plant.